Yes, I think
Yeah.
the recording is started now. You might have gotten the notification. Okay. Yeah. Okay. Moma, over to you.
Okay, thanks. Yeah, so I guess I'll hit a rewind button. So, good morning and welcome again to this special event, symposium today, which marks the World Logic Day, which actually is on January 14th. As you may know, it commemorates two legendary logicians, the birth anniversary of Alfred Tarski and the passing of Kurt Gödel. The proclamation of the day happened in 2019 at a general conference of the UNESCO. And it's actually marked by various events worldwide in different countries as well as in India. So, for instance, 2 years ago, it was held in two parts at the Madras School of Economics. Last year, it was organized by the Logic Society of Delhi. The Association for Logic in India is glad to host this event, and it thanks Professor Shankho Basu for taking the initiative this year and organizing this symposium. Um, we I can see that there's an excellent lineup of talks today, and the proceedings promise to be great. Just to say a few words about the Association for Logic in India in brief, Ali. Apart from its flagship events, which are the biennial Indian School and Indian Conference on Logic and Applications, it also supports events or initiatives such as the one happening today, which dwell on various themes on logic, like seminars or workshops. Like last December itself, we had this Indian school, winter school on logic and applications at BITS Goa. And we would be having the ISLA this year, later in summer, most likely. Then the last ICLA happened in 2025. We look forward to having the next one in 2027. So Ali is open to supporting these kinds of events which foster cooperation and development of logic in the country. And I'm glad that we are able we have this we are having this symposium today. And without further ado, let me welcome you again and hand over to Shankho to carry over the day's proceedings. Shankho, all yours.
Thank you, Muhadi. Again, a warm welcome to all of you to this one-day symposium marking the World Logic Day. Our first speaker today is Dr. Abhishek De. He's an assistant professor at the School of Interwoven Arts and Science at CREA University, and he has recently come back from a position at the University of Birmingham. Today, before he starts, I mean, this is befitting that today the first speaker is Abhishek, because this year, the last year, in fact, it's already last year. It's very hard to wrap your head around the fact that it's already past 1 year. So he won the Bimal Krishna Motilal Logic Prize and presented his work in the Unilog at Peru. He did a fantastic job with that paper, and he's going to speak more about that today, I guess. Over to you, Abhishek.
Congratulations from all of us to Abhishek. Yeah.
Thank you very much. So let me share my slides. Just a second. Can you see my slides?
Yes.
Cool. So thank you again very much for the introduction.
Can you make it larger?
Sorry.
If not, you continue. It's my problem. My problem with my eyes. So please continue.
Oh, okay.
You can manage. Please continue. Yeah.
Okay. Okay. So this talk is about what is called Vukasevich logic, but the idea was that I mostly work in fixed point logics, and many valued logic was something quite new to me. So I was tinkering around with many valued logic, and so this is how the work came about. So first, I'd like to start with the principle of bivalence, which is a sort of idea that is prevalent in logic, which says that every proposition basically has only two truth values. It can have only two truth values, either true or false. And there are various criticisms of the principle of bivalence, and it can go back to as far as Aristotle, where in his famous interpretations, he writes this famous sentence where he says, argues about the sentence, there will be a sea battle tomorrow. And if you think of this as a proposition, then talking about its truth value can be problematic because you don't know whether you can assign truth or false to it currently because it is going to be tomorrow, right? So the question was, could you even assign a truth value to this statement? And one possibility which Vukasevich suggested was to deal with such situations is a three-valued logic where you have true, false, and something like as yet undetermined. And this concept is not new in, for example, non-Western logics. For example, in Indian traditions of logic like Chatushkoti and Chaptabhangi, we have propositions getting many values, like something being both true and false, or something being neither true nor false, and so on. From a mathematical perspective, considering more than two truth values also makes sense. So imagine we want to talk about the truth value of mathematical conjectures, like things which haven't been proved yet or haven't been proved to be false yet, right? So like the twin prime conjecture or the Riemann hypothesis. So, and Kleene suggested again, it makes sense to consider three-valued logic, where something can be true, false, or unknown, right? But again, there are criticisms of this shift from bivalence to many-valued. And Susko famously had this thesis that any logic which has some basic properties, I won't go into the details of that, but it's like structural Tarskian, then he showed that it basically has to have a bivalent semantics. So basically a large class of logics has bivalent semantics. But regardless, what we'll consider today is infinite valued Vukasevich logic. So the idea is to go from the binary of 0 and 1 to go to the spectrum between 0 and 1. So now a proposition can take any value, any real value between 0 and 1. So the set of possibilities goes from finite to uncountable, right? So it was finite, just 0 and 1. And now it's an uncountable set of the set of all real numbers between 0 and 1. I had this picture when I was giving the talk that I was saying that, you have the black and white world of the early Beatles and then the very, very colorful world of the later Beatles. Anyway, so I have a very simple language. Here I have false, true, negation, and implication. That's it. So I need to give you the interpretation or the semantics of these objects to tell you what the logic is doing. So I'll assign 0 to false and 1 to true. So that's kind of usual. And then negation, I assign as 1 minus the semantics of A. So negation of A gets the semantics 1 minus semantics of A. And if you think again in terms of bivalence, that A can take either 0 or 1, then it makes sense, right? So if A was 0, then negation of A gets the value 1. And if A was 1, then negation of A gets the value 0. But there can be interesting situations here where the semantics of A could be, let's say, 2/3, right? And so the negation of A gets the value 1/3, right? And the most interesting case is the semantics of A implies B, where I like to think of it as resources, that A implies B means that you take away A and you produce B, right? So it's minus A plus B, but then there is this one sort of to keep the semantics between 0 and 1. And if you overshoot, you take a minimum with 1. So that's the roughly the idea. And so the question is that, okay, what sort of things are true and false in a very exotic logic like this? It can be exotic if you are seeing this for the first time. So let us consider the law of excluded middle. So let's say you have a proposition P and we are interested in the formula P or negation of P. So as you remember, I did not have disjunction in my language, but I can define disjunction using implication like this. So this is standard. But now the question is, what is the semantics of disjunction? So it turns out, if you follow the definition and write it as the semantics of disjunction as the semantics of the definition using implication, and write out the definition, it comes out to be taking the minimum of the semantics of A and B, right? So if the valuation of the proposition was 2/3, then I could take, so P or negation of P would have the semantics minimum of 2/3 and 1/3, which is 1/3. So it is not a tautology, because a tautology should always have the semantics of truth, which is 1, right? So the law of excluded middle does not necessarily hold in this logic. So it is not a classical like logic, right? Even more interestingly, I suppose, is the case of the law of contradiction. So suppose you have P and negation of P, and is defined just as a De Morgan duality of disjunction now. So because you have disjunction, you can have conjunction by De Morgan duality. And we can write the semantics of A and B, and it turns out to be exactly taking the maximum of the semantics of A and the semantics of B. So now, if we took the value of P to be 0, then the semantics of P and negation of P is maximum of 0 and 1, which is 1, right? So it is satisfiable. So I can assign some value to this proposition P such that I can make P and negation of P satisfied. So this is again quite unusual. This does not even happen in intuitionistic logic, where the law of excluded middle does not hold, but still the law of contradiction is always false, right? So this is quite an interesting logic, I think. So any questions at this point? Okay, I'll move on. So now we come to the meat of the topic, maybe why I was interested in exploring this. So there are very famous self-referential paradoxes in logic. We have heard of many of them, like the liar's paradox, like this sentence is false, right? Or Russell's paradox. Does the set of all sets that don't contain themselves contain itself? And in the 90s and noughties, people started thinking about whether we can resolve such paradoxes if we work inside a world which is many valued, right? So there is a work by Bhave and later by Shepherdson and others where they have considered this situation and argued that if we live in a many valued world, these are not actually paradoxes anymore. So if you imagine that we write this object, so this is not a set, or we don't know if it's a set. So let's say we write this object, we write this set x such that x does not belong to x. And then I define this proposition, S belongs to S. And if we work it out, we'll have this paradoxical situation that this proposition is equivalent to its negation. That if S belongs to negation of, if S belongs to S, then S does not belong to S, and then if S belongs to S, if S does not belong to S, then it belongs to S, right? And obviously, P cannot be assigned a truth value in any bivalent logic. But P can be assigned the truth value of half in a many-valued situation. In particular, in the infinite-valued Lukasiewicz logic, because negation is defined as 1 minus the semantics of P. So half and 1 minus half is the same, right? So now I was interested in how to formalize this in a logic, right? So let us think of, yeah.
Can I ask a quick question? So,
Sure.
yeah, sure. Can you go to the previous slide? Very interesting that, so as you rightly said, you can't assign a truth value in a bivalent logic, but then you can assign it a value half with infinitely many values, truth values. Now, there are finitely many truth values, but not 2. Does the
Right,
situation of resolving paradoxes also, can you also do it with finitely many truth values, but more than 2?
Very good question. So yes, we can. And this is what actually Shepherdson and Perels, they explore in their paper. But as you will see, for my purposes, the formalization is easier if you have more truth values, because you now you can access a lot of analysis because you're working with real numbers, which you couldn't if you had finite values.
Oh, I see. That's very interesting. Okay. And presumably you are using the continuum in a crucial way.
Yes.
This would still not be infinite, but countable also would not probably be as smooth
Yes.
as it would
Absolutely.
be. Okay.
Absolutely. And you will see that in 2 slides.
Okay.
So let us think of formulas as functions, right? Because if you think what negation is doing, it's taking a value and returning 1 minus x, right? An implication is a function over 2 variables, right? So one way of thinking about assigning a truth value to the proposition we were talking about earlier is to say that we want a fixed point of the function which returns 1 minus x, right? So if we want to natively talk about resolving these paradoxes inside a logic, that logic should be able to talk about fixed points. So it is sort of natural to add fixed points within the syntax of this logic, right? So this is where my main interest enters, which is fixed point logic, um, which looks scary, but it's a simple idea, right? So you add this operator, which looks like sort of like a quantifier, right? So the mu x is an operator which acts on a formula ax, basically saying that x is a free variable occurring in A. And it's supposed to signify the fixed point of this function. So what we would want is that the semantics of this formula, this is now a formula, we have expanded the syntax of our language, is the same as when x is substituted by the fixed point of this function, right? So because we think of a of x as a function, mu x a of x is its fixed point. And so if you apply a to its fixed point, you get back the fixed point. So that's the idea. So this is not a new idea, and this has been explored in many areas. So, for example, we have modal fixed point logics like linear temporal logic and mu calculus, and this is oftentimes used in computer science to express rich specifications, like something happens infinitely often or something happens after some time. You can't say after when exactly a bounded time, but after some time this will happen. There are extensions of first order logic which have been considered, like extension of first order logic with least fixed points, to define rich classes of finite models and their and connections with complexity. It happens in various kinds of algebraic logic. So if you have a logic specifying, talking about semirings, and then you add some kind of fixed point to it, you get beautiful algebraic structures like Kleene algebras and so on, which have applications in linguistics. And something which I have personally worked on is constructive fixed points, where you add such fixed point operators to constructive logics. And this is quite useful in talking about recursion if you are considering semantics of programming languages. So here's the plan. So I'll introduce the language of the logic which I'm talking about, and then I'll define the logic, which means I'll define the semantics. I'll introduce an axiomatization, and I'll give some ideas about soundness and completeness. And if Shonko allows me, and if there is time, then I'll talk about some bonus results that we have. So let's talk about the language and the logic. Okay, so we have some propositions, and disjoint from that set of propositions, we have a set of variables. And as before, we have bottom, falsity, and implication. And we have this new operator which quantifies over a variable and applies it to a function. So this is exactly like quantifiers, like this is like there exists x, a of x, something, right? If you really want to think about quantifiers, this is actually a specific kind of second order quantifier, because x is not x is substituted not with a first order object, but a second order object, which is a formula, right? So some examples, we can take the fixed point of negation, which is the example which we started with, right? Because that's what we are trying to achieve. We can take the fixed point of the identity, because x, if you think of it as a function, it's f of x is equals to x. So that's the identity function. So basically, we're taking the fixed point of identity. And you can interleave, so make complicated functions like this, where the fixed points are interleaved. Okay. So if the formula A has a free variable x, you can think of the semantics of A as a function from real numbers to real numbers. Why? Because depending on what the valuation of x is, the ultimate semantics of A will be different. So for each value of x, you get a different semantics of A, and so A can be thought of as a function. So mu x A of x, now that A becomes bound to with this operator mu x, so this the semantics of this is now just a real number. And what is that real number? It is the smallest y such that A when applied to y is less than equal to 1. So some examples are when you take the fixed point of negation of x. So it's the smallest x such that 1 minus x is less than equal to x. So that's half. Here, the smallest x such that x is less than equal to x. So it's 0. The smallest x in 0 and 1 such that x is less than equal to x, that's 0. Which means this can never be proved. This is basically the same as false. However, this is a bit complicated, right? Yeah, I mean, how do we deal with interleaving fixed points and so on? So what we do is we restrict to quantifier depth 1. For now, let us not think about interleaving fixed points like this example. So the example which I mentioned is not allowed, but the one below it, this is fine. Mu xx implies mu y negation of y, because ultimately, if you do some alpha renaming, if you just say, I will only let you use one variable, I can do that. So this is allowed. Okay. Any questions? Otherwise, I'll move on to the axiomatization. Cool. So the infinite value Vukasevich logic is something which has been studied for a long time. I mean, it is, by some accounts, it is apparently as old as symbolic logic itself. And people have, of course, explored axiomatizations. And this is the axiomatization of the infinite valued Vukasevich logic. So you have a few axioms and the modus ponens rule. So what I do is I say, of course, since I'm building on this logic, all I need to do is add more axioms to capture the new logic which I have. So these are the two axioms I add, and obviously they must have the mu operator in them. So what are these axioms trying to say? So this one basically says that f of a is less than equal to a. So if a is the fixed point of the function f, this property is satisfied. And this one says for all b, if that property also holds for b, then a is less than b, right? So a is the smallest in some way, such that this property holds. And this is enough to characterize the fixed point nature. So just a little mathematical note. The main mathematical tool that we'll be using is Brouwer's fixed point theorem, which says that every continuous function over real numbers has over this compact set has a fixed point. And the idea is basically that if you just draw a line like this, it must cut the y is equal to x line at some point. So this is, of course, a very parent like high school argument, but basically this is what is going on. Okay, so this is the mathematical tool that will be the major ingredient of our soundness proof. So what soundness says is if the formula A is provable, then its semantics is equal to 1. So what we do is we see A of x as a continuous function from 0, 1 to 0, 1. So we have to prove that this is continuous. And now we can use Brouwer's fixed point theorem to obtain the fixed point A of x. And now what is interesting is that interleaving fixed points is not a weakness, but is a necessity, because it turns out with interleaving just two fixed points, you can create non-continuous functions. So you can create this interesting function which is 0 at 0, and for all other positive values, it is 1. So it is not continuous at 0, right? So in fact, the restriction to quantifier rank 1 is a necessity, not a real restriction. Okay, so next is completeness, where we have the converse, that if the semantics of A is 1, then we can prove A. And here what we do is, instead of reinventing the wheel, we use the completeness of the axiomatization of infinite value Vukasevich logic. So if we can somehow reduce the problem to Vukasevich logic, that's enough. So what we do is, for every fixed point formula, I add a propositional constant. And then I consider a theory which are basically the axioms for the fixed point formulas, but tweaked to have the propositional constants in them. So the propositional constants represent the fixed point formulas. So now I have a propositional theory that basically mimics the second order theory. And now, using the completeness of infinite valued Vukasevich logic, showing completeness is not that difficult. But this also only works because fixed points are not interleaved. The fact that you can have new propositional constants for every fixed point formula, and you can do this trick of defining a theory, is only possible because you don't have interleavings. In particular, that, yeah.
5 minutes, okay?
Sure, thanks. Right. So all this is not usual. So what usually happens in fixed point logics is that one restricts to so-called monotonic formulas where x occurs positively in x, and this syntactic monotonicity gives you semantic monotonicity. So if you construe the formulas as functions, they are monotonic functions. And then we usually use lattice-based fixed point theorems to give the semantics. And this direction has also been considered in the case of infinite value Vukasevich logic, but this is not what we want, because in particular, this approach will not allow you to take fixed points of negation of x, because 1 minus x is not a monotonic function. Monotonic as in increasing, which was our main motivations to study this logic. On the other hand, such an approach allows you to interleave fixed points. So basically, our approaches are quite orthogonal. Okay, I'll quickly breeze through the bonus results. I'll not talk about this one, but if a question comes up, I'll talk about this. So in a 2016 talk, Kazuchika Terui sort of informally talked about using Brouwer's fixed point theorem to prove soundness of logics. He was coming from a set theoretic motivation, but he claimed something that was quite unusual. He said that, so usually, at least what I showed here is that Brouwer's fixed point theorem implies the soundness and hence the consistency of our logic. But he says it's also the other way around. Like the consistency of our logic implies Brouwer's fixed point theorem. And so this is not a very formal statement. And I think the way to formalize this would be through reverse mathematics. So reverse mathematics is this program which says that what is a minimal set of axioms needed to prove a given theorem. So if you imagine something like Euclidean geometry, an interesting question could be, okay, I have a theorem of Euclidean geometry. I use the parallel postulate, but was it necessary? And one way to solve this is to say that it was necessary, because if I add that as an axiom to the other axioms, then I can derive the parallel postulates. So which is and you have statements like this which are equivalent to the parallel postulate in this way, like sum of the angles of a triangle is 180 degrees, Pythagoras theorem, and so on. And Simpson's program is to do the same sort of thing in subsystems of second order arithmetic. Second order arithmetic is chosen because most of pure mathematics can be formalized in second order. And it is a very surprising and interesting result that all of mathematics, most of pure mathematics, all theorems that you can think of that you learn in a usual undergraduate degree in maths, all of them fall neatly into 5 categories, which are called the big 5. And in this setting, if you try to formalize what Terry claims, it doesn't work. So I'll conclude. So the axiomatization, so in future, there are some little things to be ironed out. So one is that the axiomatization was infinitary because it was an axiom schema of sorts. And the question is, could we make that other rule into a rule, from an axiom to a rule, so that we can have finitely many axioms? And that is not straightforward, because in logics like this, the deduction theorem does not. And the point is that in Lukasiewicz logic, we do not have Craig interpolation. And the classic example is a formula like this, whose only interpolant is half. And half cannot be represented syntactically. But now, if we expand our syntax, we do have formulas which are basically syntactically half. Syntactically, we have formulas whose semantics is half. So now the question is does this larger logic have interpolation? And that's all. Thank you.
Thank you, Abhishek, for this nice talk. Now we can have a quick 1 or 2 questions if there are questions in the audience.
Yes, may I?
Please, sure.
Yeah, Abhishek, I was just curious from the technical point about the axiomatization, why you had to split your new 2 axioms, right? Split into 2. I mean, couldn't you have simply stipulated one axiom saying, expressing the fixed point, or there is an issue?
So the point is that what you could do is to say, so here, imagine in the first one, if instead of an implication, it was an equivalence, right? So a of this fixed point is equal to that. So it basically says, it would just say it is a fixed point.
Mm-hmm.
Now, the problem is, I want to say it is a least fixed point, because I want some sort of uniqueness,
Mm-hmm.
right? So so a function could have many fixed points, but then a formula can only have one semantics, can have only one interpretation. So to impose this uniqueness, I choose to interpret as least fixed points. So then I have to somehow say that it is the least one. How do I say it is the least one? And so that requires this extra quantification.
Yeah, thanks.
Any other questions?
Yes.
May I ask
Sure.
one question? Moko? Yes. May
Yes,
I?
please go ahead. Please go ahead.
Yes, Abhishek, it is. My question is basically about the relevant, about the importance of this approach from the standpoint of philosophy of logic. Can you say something about that? I mean, why? How does it help in the understanding or ontology, etc., of a logic? Can you tell us something about that?
So I have tried to think about this. So the thing is that I was always when I was reading Bhave's paper, I was always confused at when he's working inside the logic and when he's working outside the logic. Because ultimately, what he was trying to show was that if you are inside a many valued world, um, the usual self-referential paradoxes that we know, they are not paradoxes anymore. And my motivation was to sort of say that, you know, if we have a formalized setting, the one thing that mathematical logic can claim is that there is a very nice distinction between logic and metalogic. Like whether you are proving things inside a logic or whether you're proving things about a logic. Um, and and this distinction was not clear, at least when it could be something that I am not very good at reading philosophical logic texts, but it was not clear to me when I was reading that paper that when he was working within the logic and when he was talking about the logic. And so I thought, okay, maybe it makes sense to sort of expand the logic in such a way that you can talk about more things inside the logic. So, for example, like when you are proving completeness of this logic, which I mentioned, I don't care whether you are using classical reasoning or anything like that, because you are in meta logic. What I only care about is that inside the logic, you are in a many variant world. Hopefully, this makes a little bit of sense.
Okay, thank you. Is it SM Bhave?
Yes.
Abhishek, was it SM Bhave?
Yes.
Okay.
Okay, so we are out of time actually. So let's thank the speaker again.
Thank you.
And we move on to our next. Our next speaker is Professor Gopinath from the Indian Institute of Science. He's a professor of computer science and automation at IISc Bangalore, and he's going to be speaking on the didactic value of Indian logic, which was a paper that was submitted for the Bimal Krishna Motilal Logic Prize as well, and it was highly praised by all the referees. So I would, we are all eager to hear this work, which is from a different field, Indian logic. So Professor Gopinath, please, the floor is yours.
Yeah. Hello, can you hear me now?
Yes, we can hear you.
Okay. First I should mention that I retired from Indian Institute of Science about 4 years back, and I'm currently with a university in Sonipat called Rishihood University. Okay, I'm sorry I didn't make it clear. Okay. Yeah. So, can I share the screen right now?
Yes, please.
Okay. I think let me see. Where is the I can see this. Yeah. Is the screen visible? Hello?
Yes, but we can only see the web page of the World Logic Day.
Oh. Just a minute. I think I might have to just try to stop this, stop it and start again. I think there is something. I'm not sure how to do it. Let's see. Where is this? How do I get the? I thought this was a window. I'm not going to figure out how to get the window I'm interested in. Just a minute. Sorry, just a minute. Oh, okay, sir. I should scroll it right. Okay. Sorry, it took me some time. Okay. Now is it clear?
Yes, it is visible now.
Okay. Is it in full screen mode or is it? I think let me see. I think we should.
It's not in full screen mode yet.
Okay. Okay. Now, okay, got it. Yeah.
Yes, now it is.
Okay. So, yeah. So before I proceed, let me just mention one or two things. I'm looking at Indian logic from a didactic point of view. That is, if I'm trying to introduce logic, what are the issues that could be, we should be, let's say, could be, find it interesting, for example. And it turns out Western logic has a certain focus and is definitely very successful. But it sort of misses out some of the things that we are looking for in logic. Okay, so for example, aspects of ontology, probably epistemology, and things of that kind, which were very much areas of concern in Indian logic. So, in a sense, if we teach the mainstream logic right now, most people might not get a sense of the other aspects which are also important. So, my perspective in giving this talk is to try to introduce the amazing amount of interesting work that was done in India in thinking about some of these issues. And I'm going to touch upon a few things. I'm not sure I'll be able to, there's so much in this area that I will only be able to talk about a few things. Okay. So let me start with an interesting, let us say, incident in our cultural history. In Shatapatha Brahmana, for example, there is a person by the name of Namuji. He makes Indra promise not to kill him by day or night, not with anything wet or dry, etc. So in a sense, you can see that fairly complicated or complex logical statements were being discussed quite some time back. Okay? And interestingly, if you look at let's say how the story progresses, even though Namuchi gets this promise, Indra is able to still kill him. That's because, in some sense, he manufactures something which is actually not contained by that particular promise. For example, supposedly the solution is come up with a thunderbolt made of foam delivered during twilight. So it's neither day or night, nor is it a rod or bow, nor is it dry or wet, etc. So in a sense, you can see that some kind of non-monotonic reasoning has been applied. Essentially, in non-monotonic reasoning, you add some new facts and suddenly the previously held truths may no longer be valid. And here, for example, the fact that you can construct foam, for example, might not have been known to Namuchi, for example. And so in a sense, it creates this kind of possibilities. Okay, so you'll see a lot of stories in India have this particular way of thinking. Okay? And you can also see it, of course, in Narasimha, for example, you see the same story. And also what I just want to also mention is that if you look at Panini, he uses fairly complex logical formula for specifying when some rules fire. And so there are many instances where, if not the current style of logic, there are interesting logical issues that are being handled in Indian tradition. So let me just mention some high-level perspectives on Indian logic traditions. We see that in India, I hope you can see my mouse. Logicians are those who are skillful in pramana, means of acquiring prama or certain knowledge, while Kanadas or expounders of Vaisheshika are those who know reality or risk categories. Okay? So in a sense, you might say that Nyaya deals with top-level rational or reasoning aspects, while Vaisheshika deals with the modeling of the bottom-up aspects of reality. But what's interesting is that the system that they talk about is the conjoined one, Nyaya plus Vaisheshika. Okay? And so this interesting part that in Indian thinking, Nyaya actually has to go with some aspects of modeling reality also. If you look at the Western model, the philosophers of logic, for example, they say that Western logic is truth functional. Basically, it means that it's denotational, or meaning of an expression depends only on some function, the meanings of its components. Okay, so this is mostly, I suppose, the dominant understanding, and there is not much, let us say, issues about ontology or epistemology that are discussed in some of these areas. Okay? And in a sense, the syntax and semantics are sort of separated, and then they get back together in terms of validity and completeness, those kind of issues. Okay, so in a sense, also you might see that the Western model, the connotations which are so critical in natural language or in modeling reality, they are avoided as they're contextual, subjective, etc. And essentially, you might say that connotations are an unbounded number of adjuncts that can affect the meaning of a statement, depending on context. This particular idea also is there in Indian thinking. For example, Navya has this notion of a technical knowledge, a technical language, and they use something called delimiters to ensure that the connotations are, for example, tamed a bit. Okay, so that also is there. But the mainstream, let us say, the Indian thinking is that you have both the Nyaya and the Vaisheshika. Again, if you go slightly more into some details, basically the big issue seems to be, can we map some situation faithfully in logic? In the Indian point of view, the often said thing is it's either difficult or quite impossible. For example, Charvakas, they say that given any statement, you can have unbounded number of confounders. Okay. So, for example, in the Charvakas, they say that upadhis, basically adjuncts or undercutters, they essentially make the statement false because you can add additional qualifications that makes any statement, if it was true in the past, it could be made to be false because of adding the confounders. Okay? So in a sense, you need to carefully delimit the tacit aspects. And for example, Matilal actually calls Indian logic as property location based. So you need to add location, other kinds of stuff to actually contain the meaning of something. Okay? The real problem with this kind of approach is that analysis becomes difficult because you have to carry around the delimiters. And if you have studied the Sanskrit language used for logic, it's quite tricky. Okay? It's not easy to understand. Okay? I think my understanding about the Western point of view can be summarized as that this also is difficult, definitely, but we can go with some modeling or mapping. Okay? And so basically, in some sense, you throw away those things which are not really necessary for you right now and proceed with it. The real issue is how much can we throw away? And the real problem is if you have thrown away something, can we map it back to reality later? For example, in our current, for example, if I take my laptop, it has got lots of electronic bits, but they may suffer, for example, a cosmic ray impact and probably flip the bit. So I don't know exactly what it is computing when some bits are flipped. Okay, so the reality actually can be very tricky to model, and it can be problematic. And for that reason, for example, in earlier, sometime in the past, in the 1950s, there was a mathematician, philosopher / machine translation expert, Bar Hillel. He actually has written he has mentioned, he complains that logic, which was supposed to be, let us say, deal with argumentations in natural languages, the current models of logic really don't do that much. Okay, that's what he says. Okay, of course, right now, given the advances in artificial intelligence, LLMs, etc., LLMs, for example, seems to be doing some of this kind of stuff. Basically, if you look at sentiment analysis, basically, probably they are doing something in this area, but they are using statistical inferencing, but not standard logic. Again, that's what I would like to say. Again, just to go further, if you look at Russell, for example, he says that if you look at inference, for Malone is essential, the particular subject matter is irrelevant. Okay? And again, he says, for example, that no particular things or properties are mentioned in a proposition of pure logic. Well, the proposition is absolutely general. In logic, it's a waste of time to deal with inferences concerning particular cases. And this kind of opinion also is there in our Indian tradition. For example, in some of the Buddhas, Dignaga, for example, he says that inference operates exclusively in the field of universals. Okay. Basically, the concern would be that if a particular is involved, it may have some or even unbounded incidental properties that might interfere with some property in the discussion. For example, if somebody says birds are uniquely evolved from reptiles to specialize in flying, the word uniquely is a problem because bats also can do it. They have also evolved. Flying, for example, you can have birds which don't fly also. So in a sense, if you give some specific things, you may not be able to, let us say, go as before. Okay, so there is some problem with that. Okay, so essentially, there is argument that you need to work in the universals. But if you take the opposite perspective, for example, Nyaya Vaisheshika, you try to, let us say, ignore the initial adjuncts, assume some kind of normality, or the other opposite is what we mentioned before, they assume a default logic with non-monotonic reasoning in case particulars are encountered that are not normal. Okay, and you can see that this particular perspective is then the naming of the system itself. For example, it says Nyaya Vaisheshika, and Vaisheshika means something special or particular. At a deeper level, one can argue that even Russell's position is untenable because, for example, if you, some of the paradoxes you get only when a specific sentence is substituted in a general logical statement. Okay, and there's a beautiful example that Tarski himself gives in Scientific American. He wrote an article in Scientific American, page 65, June 1969. He says, for example, he introduces a general statement, P is true if only if P, and then he constructs a sentence, which is a very specific sentence. This in this particular paper, okay, on this page 65. The sentence printed in red in page 65 of June 1969 issue is false. And by, let's say, substituting this, he actually is able to come up with this particular, there are some intermediate steps, I don't want to go into it right now. By essentially, he shows that this S is false if only if S is true. Okay, in a sense, you can construct this antimony. And essentially, what I was arguing was that there are some specific sentences you have to substitute. You can't work exclusively in the world of universals. That's what one argument. And that's the reason why the Nyaya Vaisheshika perspective is probably also something quite meaningful. Okay? And it's not only that specifics are important, but even the epistemology also is an important issue. I just mentioned some of the things that Indian thinkers have thought about. For example, Samkhya, it states that the truth and falsity are they are present in their swata, basically they're intrinsic. Okay, and I think if you think carefully about it, it looks a bit peculiar. But if you think carefully, probably it is equivalent to the position that given a set of sentences, right? You want to you might be able to use your infrastructure to either prove it with whether that particular statement is true or false. Okay, so like in the current mathematics, right? You don't, once you are abstracted into a particular system, there's no need to interact with reality as long as they're consistent, and we can in principle axiomatize reality. And there's also the opinion of some people, like for example Wittgenstein, for example, logic is anyway tautology. In some sense, you are working in your domain, and any statement can be seen to be either true or false within that particular domain. Okay, so that's probably the implication of this. I'm just sort of reading this particular understanding from what Samkhya is saying. Except that if you think about the current computer science kind of ideas, if you take logical statements which are sort of equivalent to computationally irreducible statements or undecidable statements, then this perspective is certainly problematic. Okay. So again, you can even think of Tarski's undefinability theorem, okay, as an example which makes this particular understanding a bit of problematic. At the same time, what is interesting is that the various thinkers in India have explored all the various different perspectives here. I mentioned Samkhya is doing that truth and falsity are intrinsic. And Nyaya basically says both validity and invalidity of knowledge are extrinsic. Basically, you can argue, Nyaya argues that whatever you have cognized is nothing but a hypothesis and doesn't have any epistemic value until it's checked using some actions. Okay? And for Buddhists, for example, there's a similar perspective that all knowledge is intrinsically invalid unless verified through successful action. In a sense, unless you see correspondence with reality, there's no way to figure out whether it is true or false. Okay? So in a sense, everything is invalid until you actually validate it extensively. Okay. And there are other thinkers, Mimamsa and Vedanta, they fall somewhere in the in-between situations. And for example, that all knowledge is intrinsically valid unless corrupted by some external factor that causes distortion. And again, probably we can read in non-monotonic reasoning also as part of this particular perspective. Okay. So there are various, so in a sense, you can see that the Indian logic thinks a bit about ontology. It also thinks about epistemology, and both the things are part of Indian thinking. And in this connection, let me just mention an interesting perspective with about axiomatism and a related area called computational positivism. And this is a paper written by Rudram Narasimha. He was a professor at Indian Institute of Science. He mentions that there are two mathematical cultures in pursuit of exact sciences. That mathematical approach has historically two distinct cultures. One of them talks about deduction of certain conclusions from clearly stated axioms or models as the primary objective. Other considers number as the primary concept and emphasizes computation and algebra conforming to unambiguous rules. Okay. He names it as computational positivism, whose goal is to make computation agree with observation. And he says it is characteristic of Indian and Babylonian astronomy. Okay? So, and he says that the interaction between these two cultures have played a key role in the history of science. And so he mentions this. And basically, one can, to paraphrase what he has said, there are two types of high-level thinking. One is axiomatism, for example, the Platonic thinking, knowledge of Platonic ideas is innate, and forms provide a way of understanding world through a perfect existing model. And mathematical ideas are real, but exist as perfect forms. And essentially, there could be self-evident axioms. Or again, Russell, for example, talks about the fact that logic can capture reality. And a slightly derived version, logical positivism, which says that verifiability can be used as a proxy for truth. Of course, there are many aspects of logical positivism, but one of the critical ideas is that verifiability is a proxy for truth. Okay? And it turns out this is similar to what Samkhya has mentioned some time back. And interestingly, this particular thing was seen to be a problem by Gödel, basically that you cannot really equate them. And interestingly, even the sentence, verifiability is a proxy for truth. How do you verify this insight itself is a problem in logical positivism? Okay. Again, Tarski's insights are also useful here. So basically, the opposite perspective, most colorfully can illustrate it using Feynman. He basically says, he's of course using his domain of physics. He says there is the Greek way of doing it from first principles axioms and the Babylonian one. Okay, and he says, I'm a Babylonian. I have no preconception of what nature is, for example, what axioms are appropriate, for example. And he wants to experimentally figure it out. In some sense, is sort of more, some people look at empirical. And there is other alternative that to build models and use the models to deduce certain things, either through logic, through mathematics, through physics, whatever. And you see that model actually produces results that are concordant, it concords with the reality. Okay. And that's the only way to understand something. Okay. In a sense, you have reality, you abstract it, you have to build a model. And then of course you can do deduction using logic, for example, or predict it. Okay. You can use any formalism. It can be logic, computation, mathematics, whatever it is, or it could be recursively the same particular idea recursively applied in this part. Okay? You get the results, you check with observations and see if it is corresponding with reality. If it doesn't, then you have to remodel it. Okay? So again, if you look at things like quantum systems, even observations and modeling actually can be quite deeply entangled. So this is not exactly trivial business. At some level, if you don't take quantum mechanics systems, it probably looks very straightforward. And this is probably what everybody's doing nowadays. If you look at artificial intelligence and whatnot, probably this is what is going on. Okay? But there is some genuine complexity if you introduce things like quantum mechanics systems. Okay? So in sense, for example, if you look at physics, you say that sensing and evolution of systems through instead of observations we model. But if you look at computation, you'll see that like it's one of the interesting definition of computation I come across is by Wittgenstein. He says computation is an evolution process of some environment by a sequence of simple local steps. And here, if you look at physics, it's happening through equations and whatnot. Here is having simple local steps. And again, when we talk about quantum mechanics systems, this local aspect is basically what is going to be the problematic aspect for this kind of a model. But I guess one can think about these things in more detail and try to elaborate it. Okay, possible. Okay. So now to quickly look at some perspective of Indian logic, we'll see that the various thinkers in Indian logic, they have actually occupied multiple different areas of pramana, or basically what could be allowed for let us say how to reach truth, for example. Charvakas, for example, they only accept observations. They don't even accept inference. Vaisheshikas and Bauddhas, for example, they accept inference. Samkhya and Vedanta, they accept testimony of experts in the area, for example. Nyaya basically also goes for analogy. And there are other, for example, Prabhakaras, they have something called Arthapatti, which is basically, you can sort of see it to be equivalent to inference to best explanation. And Bhattas also say that if you're not able to derive something equivalent or deriving something, or it's not cognizable with all your efforts, probably you can unupalabdhi, you're not able to get it, then you can probably go for the negation of that. Okay? And so there are various positions occupied by various thinkers in Indian tradition. So this is quite interesting. I think if it is seen by students, they might also find it interesting how current logic also operates. I think, for example, I just mentioned briefly what Nyaya, just one or two, let's say, descriptions here. They basically say pratyaksha, perception, anumana is inference, and upamana is comparison, and shabda is basically testimony, okay, basically of experts. Okay? This, they say, is means of right knowledge. And there is interestingly, even, for example, they will say that inference is either deduction, okay, basically purvavad, okay, or it could be inverse, basically abduction, this seshavad, and samanya, which is basically induction. This what is commonness in means it is. If you see enough examples, it is basically the common one. Okay, so you can see that they talk about inference as being three components. Okay, And they even think about, for example, if an object of right knowledge is to be established by means of right knowledge, the later needs to be established by another means of right knowledge. Okay, so in some sense, there's some kind of recursive problem here. Okay, and they also say that the ways of understanding inference, it has to be through propositions, reason, example, application, and conclusion. One important thing about Indian logic is that you have to provide examples. Okay? Without examples, you cannot proceed. In a sense, you might call it a constructive kind of logic. Okay, you cannot come up with a logic which is consistent without producing any examples. Okay? That's not a reasonable idea. Okay, so again, for example, this is a standard example given in Indian text. The hill is fiery because it is smoky. Whatever is smoky is fiery as a kitchen. So this is an example here. Okay, and so this hill is smoky, therefore hill is fiery. And basically here you can see that because Indian logic is sort of grammar based, so there's a lot of discussion. Linguistic issues are part of the game. And for example, the fiery, for example, does it mean fiery everywhere or it's only one place? Okay. And smoky, is it also we can have a doubt whether it is sort of smoky because it's a vapor rather than actual smoke. Or, for example, is it true that smoke entails fire? For example, you have a red hot iron ball. It may not actually have any smoke also. So the thing is, each of these things, because it's the tradition is linguistically, let us say, based, it thinks about some of these issues. So, and again, there are a lot of questions about why there are only five members rather than 3 typical in the Western logic. And interestingly, there are various discussions. One interesting perspective is from one philosopher by the name of Wojtki. He basically says that this 5-member logic is an example of default logic due to discussion of positive and negative examples. Okay, and so let me just I'll come
5 minutes.
Okay. Yeah, I'll come in a few minutes. So basically, the example that is given is, for example, suppose you have a person X as a good candidate for a post. Okay, so X has personal characteristics similar to some good exemplar Y. Okay, exists. Okay, but so even if X is a positive example, that does not make him a good candidate because we have to show that it doesn't have any negative delinquencies. Okay, X is not a negative example. So essentially, what is happening is that you want to use the third member to show normality of Y, whereas the fourth one is used to show the fact that there are no delinquencies. Okay, so essentially, you need to provide both positive and negative aspects of the thing. Then only the inference goes through. Okay, so that's the reason why you need five of these things. Okay, so again, this importance of the examples I mentioned is very important in Indian logic. A good example, for example, is let us take this case, the Buddhist position that whatever exists is momentary. Okay? Now, suppose I want to take the opposite position. Whatever is non-momentary does not exist. Okay, so if this position has to be proved or falsified, suppose somebody says that I want to prove this, okay, then essentially you have to find an example for something that does not exist. Okay, now that itself is a contradiction in some sense. Okay, so the logicians in the school of Nyaya, for example, they argue that an unreal entity cannot be used as a subject in an exam. But if you use this, when the Buddhist says that you have yourself used it in this particular injunction, okay, that you say you cannot use an unreal entity, you cannot be using as a subject because you yourself used it in this particular example itself. So the last sentence itself has a prohibited use. So in a sense, you can see there are some intricate discussions that are going on in Indian thinking about, let us say, examples. And so I think that 5-member syllogism, or what it's called, it actually is dealing with positive examples and negative examples. Okay, so similarly, there is we have this notion of alternatives to binary logic. There is Chatushkoti, I think, which was mentioned in the previous talk. There is also Saptabandhu. Again, this is 7 modes. Essentially, it's a vector of maybe it is, maybe it is not, maybe it's indeterminate. So you find all the all the possibilities, and you get 8 possibilities. Okay, but the ones which Jainas talk about is 7 modes. The one which is 0, 0, 0 is not considered. Okay. Interestingly, if you think about Saptabandhu, it turns out Ganeri interprets this as something in the context of Aneka Antavada. Basically, what it does is it divides the mass of statements into groups of consistent subsets, each of which being a standpoint, and interprets a proposition P as having the following 7 states in the Saptabhangi. Okay? P is a member of every standpoint in S, or not P is a member of every standpoint, or P is a member of some standpoints and P is not P is a member of the rest. P is a member of some standpoints, the rest being neutral. That is not there. Not P is a member of some standpoints, the rest being neutral. Or P is neutral with every standpoint. And of course, the other one where it is there in all of, it's there in some of them. Okay, one of them. Okay, P is there, not P is there, the rest of them. It turns out that this particular model is not truth functional without refinements. Okay, so I'm going to conclude in a few minutes. Okay. Basically, I think other interesting problems were discussed. The problem of induction has been studied in some great detail. Charvakas, for example, do not accept natural induction, whereas Nayakas accepted some conditions. And there is some, there is a research that has been done which basically says that probably Hume had access to Buddhist sources, okay, because this issue is being debated quite extensively in Indian thinking. I'm not going to go into details about this one. Similarly, there is an interesting problem in logic, which Goldman comes something called the group problem. And again, I will not go into details about this because of lack of time. And basically, this is a very interesting problem. And if you look at Gangesha, he's a logician in the 13th century, he essentially seems to anticipate this particular problem. Okay, so I think what I'm suggesting is that the Indian thinkers have thought about some of these issues, and it's worth, let us say, our while to understand what they thought about and probably incorporate into our teaching. Okay. So some of these discussions, what I just talked about, is there in a full paper which is under revision. I think if you're interested in, let us say, getting a draft copy, please write to me. You can write to me at this address or at this address. In conclusion, I just wanted to mention that if you look at Indian logic and try to understand it, I believe it will open up interesting discussions, and we'll have better appreciation of various choices made in various logical formalisms. And I think that it will open our perspectives. I think that's the reason I'm calling, saying that didactically Indian logic is extremely valuable. I think that the Western logic is phenomenally, let us say, productive, and we use it all the way. But I think that Indian logic is also worth examining. Okay, and our ancestors had very original insights, and I think it's worth studying. Okay, so with this, I'd like to conclude my talk. Thank you.
Thank you, Professor Gopinath. The floor is now open for questions.
May I ask one question, Professor Gopinath?
Sure, please.
Chakravarti. Do you think that in this 5-step derivation, 5-step model, do you think there is some element of abduction there? Because some people say that it started with the effect and ultimately went into its cause. So,
Yeah.
what is your opinion in this?
Yeah, I think
about that?
I think one can agree with it. I think that abduction is also a possibility if you want to, if you are want to decide that we have to make up our mind given the facts that are available to us. Okay? So both the positive instances and negative instances, and you have to you are constrained to decide somewhere or other. Okay? I think abduction can be related to this.
And hence some sort of non-monotonicity will creep in.
Yeah, that's
Because,
yeah.
That you have mentioned already.
Yeah, that's right. I think if you look at Wojcicki's thesis, is basically that it is.
So the basic question is that, I mean, whether, I mean, is there any, say, for example, B.K. Motilal and others,
Yeah.
They want to say that it is a kind of mixture of abduction and deduction. Some people say. Do you agree with this? Or is it something third?
I think it is, there is some deductive aspects, there is an inductive aspect, and one can read into the abductive aspect if you, as I mentioned, if you are forced to say that, okay, we have these facts and you have to decide. Okay, you don't have any, let us say, additional facts that are going to be made available to you. Okay, I think probably that one can do that. Yeah.
And one more point is that they never use non-true premises.
What is it? I'm sorry.
The starting premises must be true.
Yeah.
I mean, must be agreed upon. That is something which is essentially different from the modern Western logic.
Yeah, I think that there is an emphasis on not so much. Basically, it has to be it has to produce truths as we understand in the real world. Okay, I think is the concern. Okay, it cannot be a self-consistent world which has no connection with the reality. Okay, so they want to avoid those kind of logics.
No, the basic. I think there is not enough time to continue discussion, but it was quite nice. So maybe we will get in touch later.
Yeah, sure. Thank you.
Any other questions?
Can I ask a quick question?
Yeah, please.
So in the 5-step reasoning process that you mentioned about in Indian logic, where you have the statement to be proven, then you have the reason, then you have an example, and then you have 2 more steps, I suppose. Last of which was, of course, repeating the very first, the statement to be proven.
Yeah.
So I mean, is there a certain redundancy there? Because you have the first and the last to be similar, and also what was the fourth, and what is its relation to the third?
Yeah, I think I'll get back to this. So I think basically the idea is that you have to produce the positive examples. Okay, because you are saying that you're giving an example, like for example, that the kitchen, for example, there is a smoke in the kitchen, etc. Right? That's a positive example. And then you have to also show that negative examples are things which do not contradict what you want to show. That also have to be shown. So basically, you are the third and fourth basically do that, and fifth is basically repeating that is true. That's basically the confirmation that what you started out is basically what is true. So, but the idea being that you need to show that there are no negative examples which will contradict what you're saying. So you are going to avoid the non-monotonic aspect of you want to not get into that particular area. Okay. So you basically if you introduce something which is contradicts what you started out, then you have to figure out some way to resolve it, and so it may not be able to prove what you wanted to prove it. Okay, so you're essentially in the fourth part. You're basically saying that I don't see any negative examples. You're seeing positive examples in number 3. You're going to show there are no negative examples in 4, because it says it's just like the case in 3, for example. That's why everything that I'm trying to prove is similar to what is there in 3 and without any negative examples. Therefore, I'm able to conclude.
That showing the absence of negative examples itself requires a proof. So it'll be a 2 subset. I mean, contained inside the 4.
Yeah, I agree with you. I think it's there's some recursion here. Okay? There is no question. But I think that it has to stop somewhere. Okay? So basically, it is true for any deduction also. For example, you say A implies B. You have to prove A, and to prove A, you have to go back also somewhere, right? So it's a problem about any deductive system. Okay, it's not. That's why you need to have starting points, axioms, etc. And you have to assume that by definition axioms are true. Okay, so that recursion is I think seems to be a problem everywhere. As I mentioned, even the logical positivism, they say that verifiability is a criterion for truth, right? That itself is a statement, right? How do you know that how do you prove that itself? Okay, so it's, I think essentially you have to do some meta level thinking, like Tarski talks about, those kind of things. I think it's not a something. I think all formalisms, I think, have this issue. That's the reason why whether it actually tallies with reality, tallies with, I think, an important part of the thing. So logic by itself, unless there is some connection to reality, you can't be sure about what's going on. And of course, you can live in a mathematical world where you can have some accidents and you can completely, let us say, be consistent and everything is fine. That's certain, but whether it is meaningful for us human beings or useful to us, that's something which we have to, that's something to be separately looked at.
Thank you.
Any other questions? If not, let's thank the speaker again.
Thank you so much. Thank you.
Okay, and our next speaker is Shubhojoy Sarkar. He is an assistant professor at Fakir-Chaand College in near Kolkata. He's going to take us back to Western logic, significant contributions of ancient Stoics to the domain of logic. That's his title. Shubhojoy, it's all yours.
Good afternoon, everyone. Is my PPT slide visible?
Yes.
Okay. I am Shubhojoy Sarkar, now serving as an assistant professor at Fakir-Chaand College, Diamond Harbour, and simultaneously I am doing my doctoral research from Department of Philosophy, Jadavpur University. Before starting my presentation, I want to make one. I mentioned that I am not very much fluent in English. Therefore, I humbly seek your kind consideration. The topic that I want to present before you is significant contributions of ancient Stoics to the domain of logic. If we reflect on the history of ancient logic, we find two prominent schools. One, peripatetic school, founder of which is Aristotle, and the other is Stoic school, the founder of which is Zeno. Although Zeno founded the Stoic school of logic, but it was developed further by Chrysippus on Megarian teachings. Whereas the literatures of peripatetic logicians were meticulously preserved with each detail, but no Stoic literature on logic are available today. One may say that maybe the basis of Stoic logic was not strong enough. Therefore, it had lost over time. So, but Clement, a Christian theologist, whose comment in this regard is remarkable. Clement was an authoritative Christian theologist. When he was asked who the best among the philosophers was, he named Plato. Who the best among the poets was, he named Homer. He named Aristotle as the best among scientists. But when he was asked who the best among the logicians was, he named Chrysippus. And Chrysippus was a Stoic logician. In my research, I found that Chrysippus wrote over 200 books on almost every area of logic. Argument forms, valid argument forms, paradoxes, connectives, and more and more. But also I found in my research that when Diogenes Laertius in his book, famous book, Lives and Opinions of Eminent Philosophers, said that Megarian philosopher Eubulides was very opponent to Aristotle. This is how the conflict between Megarian school and peripatetic school started. And since Stoic school of logic was developed on Megarian teachings, therefore peripatetic philosophers also considered Stoics as opponent of them. This is how the conflict between peripatetic school of logic and Stoic school of logic started. And it went for centuries, whose adverse effect was seen in the history of logic. The loss of early Stoic writings on logic presents significant challenges for understanding their theories. Since none of the primary texts on Stoic logic have survived, we are forced to rely on secondary sources. Sextus Empiricus, a Greek physician and skeptic from the early 3rd century, is our most important source on Stoic logic. His surviving books are Outlines of Pyrrhonism, which has 3 volumes, and Against the Mathematicians series, which has 11 volumes. 8th volume of his book, Against the Mathematicians series, the name of which is Against the Logicians, contain elements of Stoic logic. And another significant source is Diogenes Laertius, the author of the book, The Lives and Opinions of Eminent Philosophers. So now we'll see the contributions of ancient Stoics to the domain of logic. Stoics, for the Stoics, philosophy has three parts: logic, physics, and ethics. For them, logic holds a fundamental place in the structure of philosophical inquiry. According to Stoic doctrine, physics aims to investigate, understand, and explain natural phenomena. Ethics directs human conduct towards living in alignment with the rational order inherent in nature, and logic provides the critical tools to distinguish truth from falsehood. By enabling the distinction between what is true and what is false, logic safeguards and facilitates accurate reasoning within both physics and ethics. Thus, logic is intimately connected to and indeed supports the other two branches of philosophy. The importance the Stoics attributed to logic is vividly illustrated through a series of analogies. One traditional Stoic analogy compares philosophy to a cultivated garden. Physics is likened to the growth and stature of the plants, ethics to the sweetness of the fruits, and logic to the durable enclosing walls, guard walls. The comparison illustrates how logic functions as a protective framework, much like the walls of a garden that safeguard its plants from external harm and preserve the harmony of the whole. The second analogy likens philosophy to an egg. Ethics corresponds to the yolk, physics to the egg white, and logic to the outer shell. Here, the shell represents logic's protective and structural function. It holds the components together and guards their integrity. The third analogy likens philosophy to an organic whole, like a living animal. Physics is compared to blood and flesh, logic to the bones and sinews, and ethics to the soul. In this analogy, emphasis is placed on the mutual dependence and inseparability of philosophy's constituent parts. Taken together, these analogies affirm that while ethics is the aim and physics the substance, logic provides the framework and condition that make coherent understanding and the pursuit of virtue possible. Now we come to the concept of lecta. In Stoic logic, the relationship between the concepts of sign, lecta, and denotation is of central importance. According to the Stoics, a sign refers to the sound that we hear. Denotation refers to the external object connected to that sound, and lecta is the meaning that the sign conveys. For example, the spoken phrase, the founder of Vishwabharati, serves as a sign. It denotes the historical figure Kaviguru Rabindranath Tagore. This is the denotation. However, understanding what lecta represents is especially important. Consider the phrases the author of Gitanjali and the founder of Vishwabharati. Both refer to the same person, same denotation, yet they express different meanings. The first highlights Rabindranath Tagore's authorship of a specific work, while the second points to his role in founding Vishwabharati. these different meanings represent different lecta, even though the denotation remains the same. Here, the observation is that the Stoic distinction between sign, lecta, and denotation closely resembles Frege's well-known triad of sign, sim, zin, and bedeutung. In Stoic framework, there are two types of lecta: defective lecta and complete lecta. Defective lecta means incomplete expression. For example, rights. When we hear the word, some incompleteness is there. Who writes? And complete lecta represents full, meaningful expressions. For example, Socrates writes. Here, the observation is that the Stoic differentiation between defective and complete lecta aligns with Gottlob Frege's distinction between incomplete and complete expressions. Within the here also we find that defective lecta has a property, has a functional property. Defective, just like function. In function, we have an argument place. Lecta, for example, Dash is a poet. If we put Sachin Tendulkar in the emptied place, we find that Sachin Tendulkar, we find a complete expression, complete lecta, that is Sachin Tendulkar is a poet, which is considered as false. If we put Rabindranath Tagore, then we find Rabindranath Tagore is a poet, which is true. The Stoics categorized the following under complete lecta. For example, imperatives, oaths, invocations, puzzles, exclamations, questions, assertables, curses, etc. In this different type of complete lecta, only assertable hold central importance in Stoic logic, because assertables are truth functional. In Stoic logic, assertables are categorized into two categories: simple assertables and non-simple assertables. Simple assertables are further classified into 6 types: definitive, indefinitive, affirmative, negative, denial, and privation. Definitive non-linguistic gestures are there to validate the assertion. For example, when we say, "This is the book I was talking about," while indicating the book, it is definitive, because here there is one assertion, that is this is the book I was talking about, and also there is non-linguistic gestures. Indefinitive assertables consists of an indefinite particle and predicate. When we say someone is walking, here someone functions as indefinite particle and each working functions as predicate. Affirmative assertable consists of noun and a predicate. In this example, Dion is working. Dion serves as noun, each working as predicate. Negation. Negation consists of a negative particle and an assertable. In the example, not, it is raining, not serves as negative particle and it is raining as an assertable. Denial. Denial consists of a denying particle and predicate. No one, in the example, no one is working. No one functions as a denying particle and each working predicate. Privation. Privation consists of a privative particle and an assertable. This, in the example, this man is unkind. Un serves as a privative particle and this man is kind as an assertable. In this classification, the first three are categorized as affirmative assertable and last three as negative assertable by renowned Stoic scholar Susan Bobsian. So here some important observation is there. When one may say that for a negation, for negative assertion, only one category is enough. That is negation. Not, it is raining. Denial and privation, they can tell that denial and privation can be transformed into negation. For example, no one is walking can be transformed into not, someone is walking. But this man is unkind, can it be transformed into not, this man is kind? So here one may question that if both denial and privation are convertible into negation, why then accept them as separate categories? Actually, the privative assertable, this man is unkind, implies that the individual possesses cruelty as a trait, whereas the negation, not, this man is kind, signifies the absence of kindness in the individual. It does not necessarily imply cruelty. The person may simply be indifferent. This distinction highlights the existence of a spectrum between kindness and unkindness or cruelty, a realm where the principle of bivalence does not hold. To elucidate further, consider three concepts: kind, unkind, and neither kind nor unkind. For instance, Rambabu regularly feeds street dogs, leading one to assert Rambabu is kind to dogs. Conversely, Shyambabu mistreats dogs, justifying the assertion Shyambabu is unkind to dogs. However, there exists a third individual, Jodubabu, who neither feeds nor mistreats dogs, remaining indifferent to them. In this scenario, bivalence fails to apply. It cannot be conclusively stated that Jodubabu is either kind or unkind to dogs. This ambiguity hints at the presence of fuzziness. This uncertainty suggests the presence of fuzziness. It is possible that the Stoics were aware of this and therefore separated privation from negation, treating it as a separate category. Thus, privation should not be equated with negation. So also we find in the concept of negation denial that negation and privation, that negation is propositional negation. Here, the proposition or the assertion it is raining is negated by the word not, by the negative particle not. So, whereas Aristotle was aware of only term negation, but Stoics were aware of term negation as well as propositional negation in ancient time also. Also, Stoics were aware of the concept of double negation. For them, P is equivalent to not P. Now, so here two observations we found. Stoics were aware of term negation and propositional negation, and Stoics were aware also of fuzziness. Now, Aristotle accepted categorical propositions that are A, E, I, O. Can they be accommodated?
I think we have lost our speaker. Let's wait for a couple of minutes for him to come back.
Sorry, my network connection was poor, so I was disconnected. So, 4 types of categorical propositions accepted by Aristotle, can they be accommodated?
You need to share your slides again.
Okay. Now, is it visible?
Not yet.
Okay. Actually, my network is little bit poor, so I am directly presenting, but
You want to go ahead without the slides?
yes, sir.
Okay, sure, please. You have about 5 more minutes, so please go ahead.
Okay. So, let us examine whether Aristotle's 4 categorical propositions along with singular proposition can be accommodated within the framework of Stoic logic. Let us first examine whether universal affirmative propositions can be accommodated within the system of Stoic logic. Regarding Stoic views, no Stoic literature contains universal propositions starting with all. Benson Metz, in his book Stoic Logic, tells that the Stoics are nominalists. According to nominalism, universals are merely names without corresponding reality, implying that only particular objects exist. This may explain the absence of universal affirmative propositions in Stoic logic literature. Now, let's examine whether existential affirmative propositions can be accommodated within the system of Stoic logic. The structure and form of the indefinitive assertable accepted by the Stoics is identical to existential affirmative propositions. So, existential affirmative propositions also can be accommodated within the system of Stoic logic. Now, universal negative propositions. The structure and form of the assertable denial are similar to those of a universal negative proposition. Formally, there is no difference between this type of assertable and a universal negative proposition. Therefore, universal negative propositions can also be accommodated within the system of Stoic logic. However, it is important to note a potential inconsistency. Since the Stoics were nominalists, they should in principle reject any kind of universal proposition, whether affirmative or negative. While they did not accept any assertable with the form of a universal affirmative proposition, they did accept denial, which takes the form of a universal negative proposition. This presents an inconsistency within the Stoic doctrine of assertables. Now, existential negative propositions. Actually, their concept of privation or privative assertables suggests that they understood existential negative propositions. For example, the privative assertable, this man is unkind, can be transformed into someone is not kind, which is essentially an existential negative propositions. For example, the privative assertable, this man is unkind, can be transformed into someone is not kind. This thus existential negative propositions can be accommodated within the Stoic system of logic in a derivative manner. Now, singular propositions, the structure and form of affirmative assertables accepted by the Stoics are identical to those of singular propositions. Formally, there is no difference between this type of assertable and a singular proposition. Therefore, singular propositions can be accommodated within the Stoic system of logic. So, now we come to the point valid argument forms accepted by the Stoics. Stoics accepted 5 valid argument forms. The first one is if the form of the first one is if the first, then the second. The first, therefore the second. This form is identical to the rule of inference modus ponens. Second type of valid argument form, the form of which is the first, if the first, then the second. It is not that the second, therefore it is not that the first. This corresponds to modus tollens accepted in modern logic. Third type of indemonstrable follows the following form. It is not that the first and the second. The first, therefore not the second. It can be transformed into disjunctive syllogism by the rule, by two rule, law of double negation and De Morgan's law. So they accepted in a derivative manner these two rules also. the fourth type follows the following form, either the first or the second. The first, therefore, not the second. Actually, this argument form is not valid in modern sense, but since Stoics accepted disjunction in exclusive manner, therefore this fourth type also becomes valid. And the fifth one follows the following form, either the first or the second. It is not that the first, therefore the second. It is identical to disjunctive syllogism. So Stoics accepted three rule of inference, that is modus ponens, modus tollens, and disjunctive syllogism. And also they are aware of the law of double negation and the law of De Morgan's law. Stoics, according to the Stoics, an argument is defined as a combination of assertables. For them, arguments are of two types, inconclusive and conclusive. An argument is said to be inconclusive when the contradiction of the conclusion is not incompatible with the combination of premises. For example, if it is day, it is light. It is day, therefore Dion works. This argument is inconclusive because the contradiction of the conclusion, that is not Dion works, is not incompatible with the combination of the premises. One could easily deny that Dion works without conflicting with the truth of the first two assertables. An argument is said to be conclusive when the contradictory of the conclusion is incompatible with the combination of the premises. For example, if a metal is heated, it expands. The metal is heated, therefore this metal expands. This argument is conclusive because the contradiction of the conclusion is incompatible with the combination of the premises. In a conclusive argument, the contradiction of the conclusion is said to be incompatible with the premises, meaning that if one were to assume both the premises and the negation of the conclusion, a contradiction would arise. This is precisely the reasoning pattern used in reductio ad absurdum, where we assume the opposite of what we aim.
You are out of time.
Okay.
Please, wrap up.
I am concluding. Okay. So this is precisely the reasoning pattern used in reductio ad absurdum, where we assume the opposite of what we aim to prove and then show that such an assumption leads to an absurd or contradictory result. Thus, every conclusive argument implicitly rests on a reductio structure. The impossibility of holding the premises and denying the conclusion simultaneously confirms the necessity of the conclusion. So we find from the above presentation, we found several key conclusions that are Stoics were aware of both term negation and propositional negation. Stoics were aware of fuzziness. Also, Stoics were aware of some rule of inferences accepted in modern logic. That is modus ponens, modus tollens, hypothetical syllogism, reductio ad absurdum. So also some more also fourth type of categorical propositions were accommodated in Stoic logic, except universal affirmative proposition. Singular, also Stoics were aware of singular propositions, which Aristotle was not aware of. So, although Stoics contributed a lot in the to the domain of logic, but it is very unfortunate that still they do not get the respect they should have. So here ends my presentation.
Okay, thank you, Shubhojoy. The floor is now open for questions. Any questions for the speaker? If not, let's thank the speaker again, and we will now break for lunch. We will be back at 2:30 for the second session. Thank you all.